Yeah. Okay, now I'm ready.
It says mass spectrometers can be used to identify unknown molecules produced in a chemical reactions using B-field force principles. Find the mass of an ion if it is confined to the chamber of this spectrometer that has a uniform B field.
Spectrometer.
Spectrometer, that's what I thought. Has a uniform B field of 1.8 T and traveling in a circle of a radius 0.002 meters. The particles enter the chamber with 10 joules of kinetic energy gained being accelerated through a voltage drop of 25. So basically, to sum that up in a more simple way, you have a particle that's moving at a particular velocity as it enters into the mass spectrometer and it starts to go into a circle at a particular radius. So with the B field, due to the B field and velocity, you can figure out, in the charge, you can try to find out the mass. So trying to find out the mass. So what we have, what they give us in the problem is B, R, the voltage, and what they don't give you is the charge or the mass. So you have a 25 voltage, a 0.002 meters, and then 1.8 T. So first you want to find out your charge so you can solve for the mass, and you're going to use the equation E equals QV.
Why do you use that?
Why do you use Q? Because you have your energy, also it gives you the energy, which is 10 joules. So since it gives you the energy and it also gives you the voltage, you can be able to find your charge.
Right, because it's entering the chamber with that kinetic energy.
With that kinetic energy.
Yes.
So to find your charge.
And it got that kinetic energy from traveling through a voltage drop of how much?
25.
25 volts. Yeah.
Volts.
That's how it gained its kinetic energy. And this describes what happens, the amount of energy that a particle gains when it drops through a voltage drop of that and has that charge Q. Yep.
Yep. So with that equation, you manipulate it to get Q, which will be your 10 joules of your 25 voltage, giving your charge to be 0.4 coulombs. So with that, you can finally use the equation that's in your textbook of chapter 21.5, I believe. And just for those who don't know the equation, here's the equation. Your charge times your radius squared over 2 times the voltage times your B field squared. So your mass equals 0.4 coulombs times 0.002 squared. Oops, maybe I should move this over a little bit. I'm gonna do it over here. 0.4 coulombs times 0.002 meters squared over the 2 times your voltage times your 1.8 T squared. So that will basically give you 3.2 times 10 to the negative 8 times 1.8 T squared. And then your mass will be 1.0368 times 10 to the negative 7 kg. And so that will be your answer.
Yes. And that answer is the mass of what?
The mass of the ion.
The mass of the ion entering the chamber.
Entering the chamber.
Yep.
Yep.
All right. Thank you.